Welcome friends. Today I don't want to talk much, but I want to have a discussion on what is called as ANOVA analysis. What is its purpose and how we can take the advantage of ANOVA analysis. Generally in hypothesis testing, we want to compare sample outcome with respect to the source outcome, or one sample outcome compared to other sample outcome. For example, we want to compare the performance of the output of two machines. So in that case, we will apply a test that is called as t-test. But if we want to compare the performance of 3 machines, 4 machines, 5 machines, then we go for ANOVA analysis. ANOVA analysis is nothing but looking about the differences caused due to the change in machine compared to the differences of the repetition of the outcome. Either it is within the groups or between the groups. The general term here we apply is within the group or between the group. Group is nothing but the outcome of a machine. So if there are 4, 5, more than 2 machines, if we want to compare, we go for comprehensive analysis, that is called as analysis of variances. Why do we call analysis of variance? The reason is that in t-test we were comparing 2 means, but in ANOVA we are comparing 2 variances. To compare 2 variances, we must have to take the help of what is called as F distribution based on a random variable, that is the ratio of 2 variances. Here the one ratio is the between the groups, the other ratio is within the group. So if the variance caused due to the change in the group is significantly more than the variance caused due to the change within the groups, that is nothing but the repetition of the experiment for a specific machine, then we call it there is a significant effect of the change of machine over the performance. That is the basic concept why we apply ANOVA analysis. I'll show you by a table and a graph. It may be more. Now I want to show this with the help of table and graph what the ANOVA analysis is. If we have the data for 2 or more than 2 machines, the performance either in terms of diameter of the rod produced over the machine or the surface finish, whatever it is. But the main thing is that if we are looking for the machine 1, machine 2, machine 3 and so on, and then we want to repeat the value and we get the value for machine 1, observation 1, for machine 1, observation 2 and so on up to suppose n observations we have. Now here we can have x21, x22 and so on up to x2n. Now here it can be x31, x32 and so on up to x3n and so on. For machine suppose mk, so it will be mk1, xk1, xk2 and so on up to xk. Now what we are interested is we want to see the differences caused due to the change in machine. So the variances between groups is due to change in the machine, but variances within group is due to repetition or what we call randomness or we call error, etc. So now if we want to see this effect over the graph, then what will be this effect? We can now have observations. For machine 1 there may be some observation, for machine 2 there may be other observation for 4 and so on. So now if we draw a line that represents the relationship between change in machine based on the regression analysis. This is machine and this is observation Xij. So for this variation is within the group, but this variation is because of the between the group. So now we want to see this variance which is due to the machine change is how different than the variance due to the error. That is only possible to see by taking the help of F distribution. F distribution is nothing but based on the random variable F, which will be the ratio of two variances which we want to compare, and that variances are compared based on the respective degrees of freedom nu1 and nu2 in the same sequence. Here in our case this is S of machine square upon S of error square. So if we draw a average line over here, then this change of slope is because of the change in machine, but this difference which is here is because of the machine, because of the randomness. So we have to compare which variation is significantly different than the other, or both variances are not significantly different on the other. So once we have calculated this term, we can see on the F distribution how these two are different. And F distribution, we know it is this one. Draw F distribution, it is something like. Now in this distribution we will define the critical region. So this will be called F critical value with respect to nu1 comma nu2, and this area will be called as level of significance alpha, which we generally define 0.05. If now the calculated value F calculated, which is nothing but variance of due to machine square upon variance due to error square. If suppose it is over here, so if F calculated is over here, it means that P value is more than alpha, and thus likely F calculated is less than F critical. So in this case we are with the conclusion that there is no significant difference in the variances due to the change in machine versus between groups, within groups. However, if it goes beyond here and F calculated is this one, then the P value is over here. This P value is less than alpha and F calculated is more than F critical. In this case, the change due to machine is significant. So that is what the basic concept of ANOVA analysis is. In simple words, the concept where we can apply ANOVA analysis and how we can take the advantage of ANOVA analysis. The thumb rule is that ANOVA analysis can be applied when we want to compare more than two groups. But there is one basic condition that data must be normally distributed. If data is not normally distributed, we cannot apply parametric test. We will go for non-parametric test of statistics. Thank you very much.